Let's talk about the data used in this course. The following spreadsheet will be used in this course. It contains the columns first name, gender, height, and weight. First name is just obviously the first name of the person. Gender, M for male, F for female, of course. Height would be in inches, and weight would be in pounds. Some comments. If you plan on using the concepts outlined in this presentation within an Excel workbook, you may want to alert anyone receiving your workbook that it contains array formulas. This is because array formulas are not generally known to most novice Excel users and could confuse them. Array formulas have been available in Excel for quite a number of versions since at least Excel 95. If you're sending Excel workbooks containing array formulas to external clients, you may want to determine the version of Excel they are using and test your array formulas internally before sending out the workbook. Finally, when entering array formulas, you must use the keyboard combination Control, Shift, and Enter. If you just hit the Enter key, then you're not creating an array formula. It's because of this key combination, that array formulas are also known as CSE formulas, which stands for Control, Shift, and Enter. Let's talk about some array concepts. First off, I'll start off with a comment. We're all familiar with mathematical formulas from our school days. So changing from feet to inches by multiplying by 12, or kilograms to pounds multiplied by 2.2, although not given here as a traditional mathematical formula involving x's and y's and all this other stuff, it's just not too difficult for us to compute. As a more complicated example, if you want to compute the body mass index, or BMI, you need to make use of the following formula. BMI is mass or weight in pounds divided by height in inches squared, and all multiplied by 703. In Excel, this formula would look something like this: equals 703 times D2 for the weight divided by C2 for the height, squared for squaring of the inches, of the height that is, and that's what you would enter into the cell. Now, at no point would you take this formula, this particular formula here, and separate it into a BMI by gender, or by age group, or by race. It's just not necessary, since the formula is generalized. In other words, there's no BMI for males and BMI for females. There's just one BMI formula. But every time you copy a cut and paste, that is, the formula, this particular formula, this one here, into different cells, you are in fact saying to Excel that the formula is different for that particular row as compared to the same formula in the previous row or the following row. In fact, the formula is not different. In other words, this formula remains the same. It's the input data that's different. This is a very subtle point. This formula remains the same no matter how many times you cut and paste this guy. Sure, the input data will be different. This would change to a 3, that would change to a 3, and so on. The formula stays the same. The input data changes. And so to kind of make this more concrete, here's the BMI formula computed using the not array formulas, but just standard Excel formulas. And in column F, I've put in a text string what each one of the formulas in column E looks like. So in column E, it's basically equals 703 times D2 divided by C2 squared. And then what Excel would do, it would actually perform that calculation, write out the 52.07, and then move on to the next row. And it would say, oh, it's 703 times D3, which is 123, divided by C3 squared, or 35 squared, write out the 70.58, and then move on to the next row, and so on and so forth. This row, this formula in this row doesn't know about this formula in the previous row, and so on and so forth. But look, we're cutting and pasting the same formula over and over again. It's just that the input data is different. So, does this make sense since the formula is the same and only input data is changing? Well, in my opinion, the answer is no, and array formulas help to solve this particular problem. So let's talk about some array concepts. An array is a collection of items such as numbers or text strings. For example, the following is an array of numbers written horizontally. I've put a nice curly brace to begin with just to make it look pretty. I've put in a couple of comma delimited values, 10, 20, 30, 40, 50, and 60, and I ended my array with a curly brace to the right hand side, and so just to make it look very pretty. And this is what an array would look like, let's say. There's another array, but it's written vertically. So this is a horizontal array. This is a vertical array. Although I'm actually writing it down to make it look vertical, I'm using semicolons instead of commas, just to be curmudgeonly, in order to indicate that this array is actually a vertical or up and down array. Now, each of these arrays is just a collection of numbers. They could be text strings, but in this case they're numbers. The first one is called a horizontal array, and the second one is called a vertical array. Both are termed one-dimensional arrays, and we're going to focus on one-dimensional arrays in this presentation. We don't talk about two-dimensional arrays in this particular presentation. So now, given the following array, we've seen before, 10, 20, 30, up to 60, if I showed you the following formula, which is not a real mathematical formula, but if this formula, what would you instinctively do when you see it? Besides retch, I mean, you would take a look at this. Well, here's an array. You would do 10, 20, 30 through 60, and then I'm adding plus 1. Well, what would you instinctively do with this plus 1? Well, you would probably add plus 1 to each of the individual array elements, this one, and this one up to this one. In other words, it's also termed point-wise, but in this case you would probably do 10 plus 1, and you'd write down 10 plus 1, comma, 20 plus 1, and you'd write down 20 plus 1, comma, and so on all the way through 60 plus 1, 60 plus 1, and you would wind up with the results, which is an array itself. Here's a curly brace, 11, 21, all the way up to 61 with a right curly brace. That's kind of what I would think you would instinctively do. When I'm saying here's an array plus 1, what's the kind of obvious or instinctive thing to do? You would add the 1 to each one of the array elements point-wise. This 10 plus 1, 20 plus 1, all the way up to 60 plus 1. And this is the same thing that Excel does using array formulas. So now, given the following two arrays, 10, 20, 30 up to 60, and 1, 2, 3 up to 6, if I showed you the following formula, what would you instinctively do? Well, I have an array, 10, 20, 30 up to 60, a multiplication symbol, and then another array, 1, 2, 3 up to 6. Well, what would you instinctively do? Well, you would probably multiply each individual element together point-wise. That is, you would do 10 times 1, and write that down, comma, 20 times 2, write that down, and so on and so forth, up to 60 times 6, and you would write that down, and you'd wind up with the following result, which is again an array itself, 10, 40, 90, up to 360. And again, this is exactly what array does when using, what Excel does when using array formulas. Again, we're using point-wise, 10 times 1, 20 times 2, 30 times 3, up to 60 times 6. And that's kind of what you would instinctively do. Similar to the addition from the previous slide, this is what you would probably instinctively do. Now, given the following two arrays, and you'll take, if you recall the data we're using in this presentation, this is the weights, 150 all the way through to 876, and this array contains the heights, 45 through to 54. If I showed you the following formula, which is in fact the BMI formula I showed you previously, what would you instinctively do? Well, here's the BMI formula, 703 times, and here's my array of weights, 150 through 876, a division symbol, which is what's required in the formula, and then another array containing the heights, and then a caret and the number 2, which basically means squared. Okay, so it would be 45 squared, 54 squared. So what would you instinctively do? Well, you would do 703 times 150 divided by 45 squared, and the result is 52.07. Next, you would do the element number 2 in each one, 703 times 123 divided by 35 squared, and you would write down 70.59, all the way up to 703 times 876 divided by 54 squared, which is 211.19 as a body mass index. And by the way, if you're getting up to a body mass index of 211, you probably can drop the decimal places. But in any case, this is what Excel would do using array formulas. Okay? And again, instinctively, this is what I believe you would probably do, just shown this stuff. So, given the following two arrays, we can give the arrays names, and this is exactly what mathematicians do. They don't have any friends, so in any case, I'm going to say This array, 150 through 876, which is exactly our weights from our spreadsheet, I'm going to call it W. These are our heights from our spreadsheet. I'm going to call that H. So this array is now termed W. This array is now termed H. So if I showed you the following formula, what would you instinctively do? 703 times W divided by H squared. Well, you're going to do the same exact thing as you did on the previous slide. Basically, it's 703 times 150 divided by 45 squared, which is 52.07 as the first array element, all the way through to 703 times 876 divided by 54 squared, and that's 211.19. And again, this is what Excel does when using array formulas along with named ranges. A related concept, by the way, is called array constants. We'll talk more about named ranges and array constants later on in the presentation. So now, in each of the examples so far, the results of the calculation is an array itself with the same number of elements as the input array or arrays. That is, given the input array or arrays, each one of the examples shown so far yields an array. This is fine if you want the result to be an array, but what if you want to, say, sum up the elements of the resulting array? This is what the next example addresses. So, as a final example, given the following two arrays, again as before, weights and heights, if I showed you the following formula, what would you instinctively do? Sum of 703 times the array W divided by the array H squared. Well, you would initially perform the same computation on the previous slide, 703 times all the weights divided by all the heights squared, and you wind up with that array. And what would you do given the sum function around that array? The same thing that would happen if you summed up a couple of rows or a couple of columns. You would basically sum up all of the array elements. And so you'd wind up with 52.07, which is the first array element, plus 70.59, plus and so on up to 211.19. Okay, and you would wind up with 466.64. Okay, again, Excel would do the same thing when using array formulas, also involving the sum function here. But in this case, our result is the value 466.64. Although technically it is an array coming out of this. It's a single entry, just basically 466.64. You can just consider it a number. Note that the array formula inside the sum function is not written to the Excel spreadsheet. That is, there is no place where 703 times W divided by H squared is written. There's no column containing that. There's no place. It's only in memory where that is stored. Then the sum function is acted on this data stored in memory, and then the final results, 466.64, is written into a cell. Okay. Now, let's talk about arrays, array formulas from an Excel standpoint. So, on the previous slide, we showed examples of horizontal and vertical arrays. A horizontal array corresponds to a range of data within a row or an entire row on an Excel spreadsheet. A vertical array corresponds to a range of data within a column or an entire column on an Excel spreadsheet. Unlike the mathematical examples in the previous slides, the cells that make up an array in Excel can be entered using the traditional range specification or range spec, such as C2, C8, or by using a named range. One technical issue is that you cannot specify a discontinuous or non-contiguous range in an array formula. For example, you can provide the range spec C2, C8, but you cannot provide the range spec C2, C5, comma, C7, C8 because you're missing out on that C6 in there. It's got to be a continuous or contiguous range of cells to an array formula. Otherwise, it just won't work. Finally, array formulas may reduce the size of your workbook considerably over traditional formulas since you're not continuously repeating the copying and pasting and copying and pasting of a formula over and over and over again. So it may save you some space. Example number one, BMI example. Okay, so enough of the concepts. Let's learn about the mechanics of Excel array formulas by computing the body mass index using array formulas. So here are the steps you want to perform. Highlight the range of cells that will hold the resulting array. Step 2, enter an equal sign, just like you would normally do for a formula, and begin to type in the formula equals 703 asterisk for multiplication. At this point within the formula, with the formula still not complete, highlight the cells containing the weights, okay, using your cursor, using your mouse. Next, enter the division symbol, the slash. Then highlight the cells containing the heights, enter a caret symbol, enter the number 2 for squared, and finally you must hit the Control, Shift, and Enter key combination to tell Excel that the formula is actually an array formula. Okay? And what you would see in Excel is equals 703 times D2 colon D8, because you've highlighted these weights using your mouse, slash C2 colon C8, again that's a range of numbers for the heights, and then squared, and then you would hit the Control, Shift, and Enter key in order to indicate that it's an array formula, otherwise it won't work. And then what will happen is the results will look like this, 52.07 all the way to 211.19. And again, this is the results of the array formula you've entered in. Some things to note. Since we are not aggregating the outgoing array elements using, say, the sum function as we showed in the previous section, the number of array elements or rows will be the same as the number of input rows. That is, there are 7 output rows here because there are 7 input rows going in. Notice that my input and output rows are contiguous. Okay, there's no breaks, no rows have blanks in them. Any attempt to alter or delete an array, an element of an array in column E here, will be met with a stern warning shown on the next slide. You'll see that in 1 second. You can only either delete the entire array by highlighting the entire array and then hitting the delete button. You cannot delete a particular cell in the array. You'll just get the warning, and the warning looks like this. You cannot change part of an array. It's a very boring warning, but it's a warning nonetheless, so you can't change part of an array. Which, by the way, is a good thing. If you don't want, a client to go in and change something, or somebody receiving this to change a particular cell, an array formula prevents that from happening. Using standard formulas, somebody can go in and just type in the number 75 where there was normally 6,000, and Excel will happily do that. It won't happily do that at all using an array formula. If you'd like to alter the array formula, though, highlight either the entire array or an element of it, hit the F2 button to go into edit mode, make your changes, and hit the Control, Shift, and Enter key combination to finalize your changes. Again, you must hit Control, Shift, and Enter even when you're in edit mode to get out of edit mode, otherwise it won't work. You can shrink or expand the cell range or ranges appearing in the array formula by entering edit mode and changing the cell ranges by using the keyboard, and you can change the 8 to a 9 or whatever, a 2 to a 7, whatever. Or you can change the cells by using the mouse, and you can kind of move the ranges up and down using your mouse pointer. Don't forget to hit the Control, Shift, and Enter key to finalize your changes. Okay, this is extremely important throughout all of this. You must hit Control, Shift, and Enter. It took me quite a long time to stop hitting the Enter key when I'm trying to do array formulas. You must hit Control, Shift, and Enter, and you will, I'm telling you now, hit the Enter key by mistake, and you'll have to retype the formula. You'll eventually get it, and remind yourself Control, Shift, and Enter. In any case, you will make the mistake, but it's okay. Eventually you get over it. Note that if your output range is larger than your input range, the orphan cells will be filled in with the NA thing, pound NA/N/A. So basically, this, instead of saying the word "you're an idiot," it's just pound NA. If your range is smaller, the cells will remain blank. Let's talk about editing an array formula. So as we discussed in the previous slide, you have the ability to edit your array formula, and you do this by highlighting the entire array formula or an element of it and clicking the F2 button. Once you do that, you will be put into array edit mode, and you'll be able to change your formulas. Again, you can go in and change this 8 to a 7, 8 to a 7, or whatever you need to, 703 to 704, whatever you need to do. Or again, you can use your mouse to drag these colored boxes up and down as you see fit. And again, I'm going to repeat this over and over again. Hit the Control, Shift, and Enter keys to finalize your changes. Example number 2, average BMI using the average function. So in the previous section we showed an example of how to conceptually at least use the sum function to add up the BMI values. Let's try that example, but let's use the average function to mix it up a bit, as the young kids say, mix it up a bit, if they do say that. Step 1, move to the cell that will hold the resulting array. In this case the array will be a single value, okay, because I'm going to compute the average across things. So find some single value to enter in your array formula. Enter in an equal sign as you normally would with a formula, and begin to type in the formula equals average left paren 703 and the asterisk for multiplication. At this point, with the formula still not complete, highlight the cells containing the weights. Enter in the division symbol, which would be a slash. Highlight the cells containing the heights. Enter in the caret symbol, which is this symbol above the number 6. Enter the number 2, indicating squared. Enter the final parentheses, because we've started with an open parenthesis. We want to close the parenthesis here, and that's for the average function. Finally, hit Control, Shift, and Enter to tell Excel this is an array formula. And what you would wind up getting is, and here's an example of what that looks like. In column A10, or in cell A10, I have the text string average BMI equals, and it's where all the fun, in B10, where all the fun begins, equals average, left paren, 703, asterisk for multiplication, D2 colon D8 because I highlighted all the weights, divided by C2 colon C8 because I highlighted all the heights, squared. Here's the right paren, which ends the left paren here for the average function, and what you wind up getting is 66.6623. Okay, and that's just one value. Again, similar to the conceptual idea of the sum function, instead of adding, we're actually computing the average as you would normally compute the average no matter what you would do in Excel using regular formulas. The average function works the same way. It's just going to use the elements of the array instead of just elements from rows or columns. Let's talk about named ranges. So in the previous examples, we happily entered in the cell ranges in our array formulas. You can do this either by hand, that is by typing in the cell spec C2 colon C8, or by highlighting the appropriate ranges of cells using the mouse or the keyboard. Now, there's another way to enter in the same information in your array formula, and that is by using a named range. So a named range is a name you give, for example, weight or height, again, for example, given to a range of cells. Once specified, you can refer to the name, that is weight or height, in your array formulas, and you don't have to bother entering in C2 colon C8, or you have to highlight the cells. You don't have to do that. Okay. To name a range, perform the following steps. Step 1, highlight the relevant range of cells using either the mouse or the keyboard. Enter in an appropriate name in the name box, which appears to the left of the function bar. I'll show you what that looks like in a second. Hit the Enter key to make the definition stick. So here's what, alternately, you can bring up the new name dialog box by clicking on the Formulas menu and clicking the Define Name item within the Define Name group. So here's the Formulas menu, or tab. Here's the Define Names group right here. Here's the Define Names button, okay, the item, and here's the New Name dialog box, okay, and you would enter in the name of the range, and you would enter in, you can delete what this is, and enter in the range of cells that you want to refer to the name. If you are disgusted with a particular name, you can bring up the Name Manager dialog box by clicking on the Formulas menu and clicking on the Name Manager item from within the Define Names group. So highlight the name you want to delete and click the Delete button. So for example, here's the Name Manager, here's height, I highlighted that, I can click the Delete button and it'll just go away. You've effectively deleted the name. You're not going to delete the data, you're just deleting the definition of the name. Once you're given names to your ranges, you can then use them within an array formula instead of the range specification. So, example number 3, BMI using name ranges. So, very similar to computing BMI without using name ranges, here are the steps. This example assumes that you define the named ranges weight, which matches to the weight cells, and height, which matches to the height cells. So, step 1, highlight the range of cells that will hold the resulting array, that is the output array. Enter an equal sign and begin to type the formula equals 703 asterisk. At this point, with the formula still not complete, enter in the name of the range holding the weights, and that will be the word weight. Next, enter in the division symbol slash. Enter in the name of the range holding the heights, and that will be just the word height, or whatever you called it. Enter in the caret symbol above the number 6. Enter in the number 2 for squared, and again, hit Control, Shift, and Enter. And this is what you would see, equals 703 times weight divided by height squared. Hit Control, Shift, and Enter, and you will get your results the same as what we've seen before. The results will be exactly the same. In this case, you're using the named ranges of this name here instead of C2 to C8, D2 to D8, and so on. Example number 4, sum of products and the sum product formula. So in some mathematical formulas you need to sum the product of two arrays. For example, in regression you need the sum of squared errors in order to compute additional statistics. Now you can perform this type of computation either using an array formula or by using a sum product function which Excel provides for you, which is nice. In a pinch you can use the sum product function. So using an array formula, follow these steps. Step number 1, highlight the cell that will hold the resulting array, which will be a single value in this particular case because it's the sum of squared errors. Enter in an equal sign, as usual, and begin to type in the formula equals sum left paren. At this point, with the formula still not complete, highlight the first range. Next, enter the multiplication symbol, which is an asterisk, of course. Highlight the second range. Next, enter in the final paren because we started the beginning paren for the sum function. We need the ending paren for the sum function. And finally, hit Control, Shift, and Enter to tell Excel it's an array formula. And this is what you see. Sum product equals, and that's just a text string, equals sum of C2 colon C8, which is this, multiplied by D2 to D8, and finally the right paren. And the result, before we move on, again, you can use the named ranges as well if you need to. Again, if you're doing this, it would be height times weight, okay? And you can name your ranges and it would work just as well. Alternatively, you can use the sum product function by entering the range of cells for height as the first parameter and the range of cells for the weight for the second parameter. Note that the sum product function returns a value and not an array. Also, sum product does not require arrays as input but cell ranges. Now, the Excel manual says the input parameters are arrays, but that's synonymous with kind of cell ranges. So you'll see an array, but effectively just highlight a range of cells and you've got the same thing. And here's what the result would look like. Sum product equals sum product and then the first range, comma, the second range, or the first array and the second array. In either case, the result is the same. Same. Discontinuous ranges don't work with array formulas. So in all of our examples, the input data has been in contiguous cells. That is, there have been no gaps, as I've explained before. This is because array formulas do not work with discontinuous or non-contiguous ranges. One solution is to remove the gaps in your ranges. That's the easiest thing to do. Another solution involves using Visual Basic for applications to create a function that accepts two or more cell ranges that can be non-contiguous and returns an array so that you can use array formulas. This is obviously beyond the scope of this presentation, but you can find out more by navigating your browser to the following URL, and it's entitled Excel 2000 Custom Function to Turn Non-Adjacent Cells into an Array. It's very nice to take a look at that. Let's talk about array constants. So recall that we named a range of cells using the concept of a named range. Similarly, you can give a name to an array of constant values, numbers or text strings. You can then reference them within an array formula in the same way you did using named ranges. So, for example, let's modify our BMI array formula to reduce down the BMI by 20% for the females, but increase the BMI by 20% for the males. Now, one way to do this, although it's probably not the best way, but it's good as an example, is to provide an array formula containing the constant values, array constant, 0.8 through 1.2 in the same order as the data in our spreadsheet. So, for example, I've written this down to show you what the data would look like. This is not an array constant, it's just the data just so you can see what it looks like. The array constant would involve the numbers 1.2, 0.8, 1.2, 1.2, 1.2, 1.2, and again 0.8. Again, I just wrote them down in these series of cells so you would see what that looks like. Notice this 1.2 is for the male, these 1.2s here is for the males, but for this row here, 0.8 is for the females, and this row is 0.8 for the females. In order to use this properly as in an array constant, we've got to enter it in order, okay? But again, this is just an example to show you what an array constant looks like. So, to create an array constant containing these values, perform the following steps. Bring up the New Name dialog box located in the Formulas menu in the Define Names group. It's similar to what we've seen before. Provide a name for your array constant in the Name input box. In the Refers to input box, enter in an equal sign. Enter in a left brace to indicate an array constant is coming up. Enter in the desired constants using a comma if the array is to be a horizontal array, this way, or use semicolons to delimit the values if the desired array is to be a vertical array, up and down. Okay? Enter in the following, the ending brace, the right brace, to match up with this brace, and to signal an end to the array constant, and then click the OK button to define the array constant. And here I have an array named BMI array constant, and here's what the array actually looks like in the Refers to input box. Notice I'm using a semicolon between the elements in order to indicate that it is a vertical array up and down, because that corresponds to the data in the weights and the heights in our Excel spreadsheet. Okay, and notice I have the data 1.2 for the male, then female, then the male, 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 and then finally a female. And then you hit the OK button. Now, to test your array constant, just to make sure it's okay, highlight the appropriate rows or columns, depending if your array constant is vertical or horizontal array constant. Enter in an equal sign, followed by the name of your array constant, and hit Control, Shift, and Enter. If all went well, your array constant should be displayed properly. So I've highlighted the 7 rows here. We have 7 cells here. I've entered equals BMI array constant, because that's the name of my array constant. I hit Control, Shift, and Enter. And then voila, we get the data back, and the data looks good, so we can now move on to the next. Example. So, example 5, modified BMI example using an array constant. So, now, let's modify our formula to use the array constant BMI array constant. So, I'm not going to go through the entire process. You get the idea by now. So, what I'm going to do is I'm going to just highlight all the cells that I need to, these 7, equals 703 times, then I'm going to put in my BMI array constant, times, and the typical formula we've been using, D2 to D8 divided by C2 to C8 squared. Okay? Hit Control, Shift, and Enter, and you wind up with the modified results. Finally, don't forget to use Control, Shift, and Enter when using array formulas, otherwise it just won't work. And that concludes the presentation. Hopefully you enjoyed it. It's been something I've wanted to learn for quite a while, and I'm glad to pass this information on to you. If you have any experience with this, please provide some answers or some comments in the comment section, or a video response would be great. And I'll see you soon. Thanks for joining. Bye.